Hi, and welcome to day 3 of the C++ Bootcamp. We have a lot of material for you today. The first item is an introduction to C++ 11, followed by a discussion between Patrick Scheller of the Google C++ group, a developer and project manager, and Bruneau Babet, one of our compiler engineers. That interview will be interesting to people who already know C++, and who follow various compilers who are interested in the history of compiler development, compiler extensions, that kind of thing. First up, though, is the Bootcamp event of an introduction to C++ 11. In Monday's session, we ran a quick poll of attendees and found that about 80% of people who replied are still using an older version of C++. We've also had a number of questions from people completely new to C++. So this topic is going to show a snippet of C++ 98 code, i.e. code written in an old style. It's not bad code, but it's not great. I'm going to very quickly run through this and explain what each piece does for those completely new to C++. It covers containers, standard algorithms, streams, loops and iterators, and classes and structs. But then I'm going to examine this with an eye to updating it and go through the code and edit it live to make it a bit more up to date. Since it's artificial example code, it won't end up perfect, but it will show some of the new C++ concepts, and importantly, explain why I've made those changes. Because this is a lot of material, there's a lot to cover, but that's what a bootcamp is all about. We will go through things fast, but the replay will be available, and at the end I will link to a number of resources to find out more and to learn at your own pace. So let's begin. Remember, after this we will have a Q&A, and then we'll go straight into the more technical conversation about compiler history and extensions with Patrick and Bruno. I have here roughly a page of code. This is a command line or console application. I'll show the bits above this later, but let's look at the code on the screen. For those completely new to C++, I'm going to give a quick overview of what it does first. I'm not going to explain what a class or object or a pointer are, but we can answer that in the questions or point you at resources if you need. If you already use C++, stick with us. We'll get onto the C++ 11 items soon. This is going to go very fast. If you have a C++ Builder starter, don't bother about following along at home. We'll put the replay up and you can download the code and have a look in your own time. And just a reminder, this is old style C++. It is not very good code. We'll fix all the problems very soon. The top 7 lines are 2 example containers. At the top is a vector called items. A vector is like a dynamic array, that is, it is an array or list of items, and the number of items in the list can be expanded or shrunk. The angle brackets indicate this is a template, that is, a vector of ints. The items it contains are ints, or numbers. A template is a generic thing, where you fill in the generic spots with something specific at compile time. So the vector has been written to hold any kind of item, and we're telling the compiler to replace the unknown generic type with a specific one, int, so we get a vector of ints. You could get a vector of strings or a vector of apples, anything, just as long as you specify a real type to use. The stud : at the beginning indicates it's in the standard namespace, something that doesn't really matter at the moment. We go on to add 3 numbers, 3 ints, to the items vector. Below it is a map. A map is a fantastic data structure often called an associative array, which is a way of saying it stores a bunch of key-value pairs. For any key, you can look up and see if the value exists and what it is. It's like an index. You could associate a person with an ID code, for example, and the key is the ID code and the value is the person. Then when you give the map the ID code, it gives you the person for that ID code. Here I'm adding a key of 1, that's the ID, with the value of a string or text, 1, ONE, and so forth for 2 and 3. Below that is an example of using I/O streams. I/O streams can be used to read and write to the console, to file, etc. Here we're writing out to the console. WCOut means wide character out, and we're using the wide version because that accepts Unicode. Often, if you're learning C++, you'll see just cout or cin. The double arrows are an example of an overloaded operator. An operator is something like add or multiply, The double angle bracket is usually a bitwise math operation, but has been overloaded, that is, given a custom definition, so that they write the items they've been given to the stream. It's too much to get into now and is arguably a good example of confusing code, so we're using it just because it's common. Here we are printing to the console the values for various keys in the map. If I give it the number 2, we should print out the string 2, because that's what we associated with the number 2. If we give it 5, there's nothing there. We will print out nothing. Now we get to something much more interesting. The standard library, which is something you'll use a lot in C++, has much more than containers. Among other things, it has a family of algorithms, that is, standard algorithms you can apply to a range of items. That can be to sort items, to find items, etc. Well, here we're just going to do something to every item. That is, for each item, we're going to do something. I'll come back in a moment to what that is. Next, we have a loop, which loops over all items in the vector and prints them out. Both these use iterators. An iterator is something that points to or refers to an item in a range of items, and can be moved to refer to the next or previous one. A vector or map are just collections, and so you can have a loop that starts at the beginning or first item, is incremented to refer to the next item until it gets to the end. An iterator has pointer semantics, so you can dereference it to see what it refers to. If you're interested, you can do that by operator overloading again. Operators star and arrow can be overloaded by any class. We're not going to cover what a pointer is today, but in C++, the star lets you dereference a pointer to access what it's pointing to. The arrow operator dereferences and lets you access that item's fields or methods. Here the iterator is pretending to be a pointer because an iterator, as something that refers to something else, is similar in concept to a pointer. Don't forget, we can give you many references to learn about this later. Finally, we have an example of a dynamically created object, that is, an object created on the heap. Here one is created using new, which allocates memory in the heap, which is what you normally think of as computer memory, and makes an instance there. It calls a method on the object, and then gets rid of it. It's important to always delete what you knew, otherwise you end up with lots of memory that's used even when you're done with it, and that's called a memory leak. The heap is opposed to the stack, which is automatically allocated and freed. In C++, you can create objects on both the heap and the stack. The two variables items and map are created on the stack. Foo is on the heap, and you can see that because it is created using new and we refer to it by a pointer. That's all going very fast, but is a very quick introduction to C++ and some basic concepts. Containers, templated types, iterators for looping, algorithms, and creating and deleting. We'll make this code available and you can run it and see what it does, and running the code and stepping through it is a good way to see how it works. To do that, place a breakpoint anywhere in the code, and click this button to run with debugging. It will run until it hits the breakpoint. You can then step, that is, run line by line, or click run again, which will make it run without stopping until it hits this breakpoint that I placed at the end. You can switch over to the console to see its output. Now onto the C++ 11 part. This code is not modern C++, and I'm going to point out a few items that are not. We initialize the vector and map by manually adding elements. We use a functor for our algorithm. We loop using begin-end, and we manually control the lifetime of foo by manually deleting it. I haven't dwelt on the functor struct since we're going to get rid of it, but it is a small class or struct that has an operator bracket, allowing it to be used as a function object. So let's go through and change it. The first step is to make sure we're using the new Clang compiler. Go into the project options and in the compiler settings make sure Use Classic Boolean Compiler is not checked. Before really getting into C++ 11, a bit of code maintenance, again for those new to C++. The Let's move the foo class to its own unit. This is an organization and style thing but makes the code neater. You can add a unit by right-clicking on the project and selecting Add New Unit. C++ often splits things into two files, and you put the declaration of the class into the header, which is included into other files that lets the other files know about whatever's in the header, such as this class declaration. Here's the declaration of foo. Let's make sure it's just the declaration, that is, just saying what exists. There are no method bodies in the header. And it's implemented in the CPP file. The colons here indicate scope, so the constructor or doSomething method of the foo class. The same syntax is used for namespaces, which we won't get into today, but std : is a namespace. Back to the main code. Look at all this code manually adding items to the vector and map. Wouldn't it be nice to be able to declare and initialize the container in a single statement? Yes, it would. And one of the smaller features in C++ 11 is new initialization syntax, which we're going to take advantage of here. To the end of the vector items declaration, add the elements inside curly braces, like so. Now you can delete the manual addition of items. Neat, isn't it? This is uniform initialization syntax. In old C++, there were several different syntaxes for initializing things. Let's do this for the map too. A map takes two items at a time though, so how do we declare those? It's actually quite simple. You declare each pair, where each pair is also initialized using the same uniform initialization syntax. I'm going to put those on different lines so it reads more clearly. Already we've written less code more clearly, and as a side effect it will actually perform better too. One of the big new items in C++ 11 is Lambda Functions. There seems to be a bit of mystique about them, perhaps because of the name. They're actually quite simple. And let me take a moment out to talk about them. Lambdas are anonymous functions, i.e. just methods without a name, and can be written inline instead of externally somewhere else. That's all. It's really much simpler than you might think. The one extra really useful thing is that they can bind to or capture other variables by value or reference, to make those variables accessible inside the function body. They also behave like objects, so you can assign them to a variable. They have three parts. The variable or capture list, square brackets, this is the only unusual part. The argument list, in round brackets, just like a normal function. The code, in curly brackets, just like a normal function. For example, this lambda, where you have int n equals 5, the lambda in square brackets, n reference, in round brackets, int I, and in curly brackets, return I plus n, binds to n, which is a variable outside the lambda by reference, and when called has a single int parameter and returns the sum of the two ints. For what it's worth, that makes the simplest lambda this amazing bit of code, bracket bracket, bracket bracket, bracket bracket, which is a lambda that captures nothing, is past nothing, and does nothing. So let's go back to the code. We can write a lambda that captures the map by reference since we don't want to copy it, and then does exactly the same thing as the functor except inline here in code. The neat thing about this is that you can see what your code is doing. A functor is external. What it does is declared somewhere else, so you can't necessarily see it. A lambda you can see, so you can read your code and see what operations you are applying right there. By the way, as well as being inline in code, lambdas are inlineable and optimizable, so you lose absolutely nothing in performance compared to a functor. Let's delete the functor now. Deleting code is always a good thing. This lambda is run on each item in the range begin to end of items, which is a very simple algorithm. It is effectively a loop, and so for each item uses it as a key into the map and prints the value for that key. Next, let's talk about type inference, or the auto keyword. I want to suggest up front that you don't use this keyword everywhere, but in many places it can be very useful. Auto lets you not write what the type of a variable is, but lets the compiler deduce it for you. This is useful, for example, with lambdas. A lambda is an object, it is a function object, and so if you want to assign a lambda to a variable, why try to figure out its type, even if you can? You don't care, just let the compiler figure it out. But let's look at another use case, iterators. Suppose I change items to be a list instead of vector. List is another container. All of a sudden, the loop here won't compile because it specifies a vector iterator, not a list iterator. So let's say we don't care, it's something the compiler can figure out for us. We use auto. Now we can change the type of the container and not have to update our code. This is important because updating the type of the iterator is not a meaningful change. It adds nothing to our code. It's just bookkeeping that makes life difficult. Not having to do it makes refactoring and changing types, like changing the underlying container, much easier. This is a goal of C++. Back in the days when the STL was being written, the algorithms were designed to work regardless of the container they were operating on. Notice that we never got a compile error at the for each when we changed the type of items. It works on both a vector and a list. It was templated. The interface of using begin and end iterators was the same, even if the types of the iterators were different. Being able to do something like change a type but keep the algorithm is a design goal. Auto, in this situation, lets us achieve something similar in normal non-templated code. The compiler deduces the type and uses that for the variable. So it's great for code like this. Auto is very useful in templates too, for example for intermediate variables in a templated function. However, don't overuse it. If you write auto I equals 5, you're not really gaining anything. It's useful for where types can change, or where types are lengthy or complicated, or where you don't actually know what type you'll have. But we're not done. C++11 has what's called a range-based for loop, where a range is something like all elements in a container. Here's the equivalent of the loop with all the iterators. Auto I : items. It's neat, isn't it? You can have a method return a range too. This example is simple since it goes over all elements in items. But you could use this to go over the range of a filtered subset of items too. Finally, I want to discuss the lifetime of objects. Stack-based objects have a lifetime controlled by their scope, such as the block they are declared in. But dynamically created objects have to be manually deleted. Now, even in old C++, you're probably already using smart pointers via the boost library perhaps, but if you're not, a smart pointer is an object that looks after another object's lifetime. You give it a pointer and at some point, depending on what kind of smart pointer you're using, such as when the smart pointer goes out of scope or the last reference to the pointer it holds decrements to 0, the smart pointer's pointer, like the pointer that the smart pointer holds, is deleted. In C++11 there are two types of smart pointer, unique pointer and shared pointer. Shared pointer might be familiar to you from Boost. Let's go ahead and make this a unique pointer. We can delete the delete line because foo will be deleted when the unique pointer goes out of scope. For example, if I put extra braces around it to create an extra block, it will go out of scope here at this close brace, and that's when foo will be deleted. Let's look at the declaration of test too. It takes a pointer. Well, we know right now that foo exists because we have the code in front of us, so it's better to change it to a reference. And because a smart pointer has pointer semantics, you can dereference it in the call to test. Now, here are two possible mistakes. First, because you have a unique pointer object, you might want to pass that to the test method. If you do that by value, you change ownership of the pointer and you will not get the result you want. If you do it by reference, sure, it will work, but why? The smart pointer is used for ownership, and passing one around is confusing, indicating that you might want to change ownership. Here, just pass a reference to the foo instance instead, and leave the unique pointer at the base level. It's much clearer and cleaner. The second mistake you might make is to use shared pointer instead of unique pointer. Now, shared pointer is really useful when many places might refer to the same pointer and you only want the pointer to be deleted when the last reference vanishes. It keeps a reference count for the pointer. It's very easy to use, whereas with unique pointer, ownership changes, which can be confusing until you understand it. I won't get into the details here, but I'll add some resources at the end. However, it is less performant because it needs to keep that reference count in some external place, and does so in a thread-safe manner too, that is, with an atomic increment and decrement. It's also perhaps confusing. Using a shared pointer clearly indicates the pointer is supposed to be shared. Here, the pointer clearly is not. There is no other object also using it. I've seen a lot of code using shared pointers where doing so obscures the ownership of the pointer, where the lifetime can be controlled in a much more fine-grained manner. Try not to do that, it's unclear and slower. And similarly to passing a unique pointer as a method parameter, passing a shared pointer can be a code smell. You should do that when you need to, because it indicates something in the method will also take a reference to the pointer. But often a method can just take a pointer or a reference instead of the smart pointer object. In the end, that makes the ownership semantics much clearer. So let's look at what we have. I've removed the stream code because I don't personally like streams very much, and because I included them only so you can see the behavior of the code when you run it at home. For example, you can see when foo is created and deleted, and experiment with different types of smart pointers or with not using one at all. So here's the before code on the left and the after code on the right. You can see the C++ 11ified code, which is still not perfect but is better, is smaller, cleaner, has less code, has clearer code, looks after its object lifetimes reliably, and will be faster and easier for the compiler to optimize as well. That's good stuff. So that's a C++ language deep dive. A quick introduction to the language, and then some typical old-style C++, and then some of the major C++ 11 features and the benefits they bring. Let's move on to a Q&A, and then after this we'll show a great technical conversation between Patrick Scheller of the C++ Google Plus group and Bruneau Babet, one of our compiler engineers. Stick around for that if you're interested in history, compilers, and so forth. So there are quite a few about replays and that kind of thing. Yes, we have replays of each day's session up. Monday's is up already. I think yesterday's is not up yet, but it will be. And that will be on blogs.embarcadero.com. And we'll put today's session up as a replay. Well, we have two things today, actually. We have the conversation up next. We'll have the replay of both of these up soon. So there was a question, had a string in the code, so L and then in double brackets 1, and the question is, what is the L? So L means that the string is made up of wcharts, that is 2-byte characters, not 1 byte. So for some Unicode, for example, there are a number of different ways of specifying the way a string is encoded, and that just happened to specify that this particular string is supposed to be Unicode with 2-byte characters. So let me just scroll through some of the other questions. Is it possible to create a true alphanumeric sort? Yes, well, you can sort anything by any criteria. So with the containers, for example, you can pass in your own Lambda or some other functor if you want to sort using one of the standard algorithms as well, if you wish. Alphanumeric sort is actually quite difficult because of locale issues with strings. So once you leave sort of the plain Latin characters and get to unusual Latin or non-Latin characters from other languages, sorting can actually be a very difficult problem. But as long as you have an algorithm that you're happy with, you know how you want to sort, yes, you can absolutely sort anything however you want. And let's see, there are a few more questions coming in while I'm talking. I may also want to mention null pointer versus null. That's an excellent point, so thank you for saying that. I was trying to go through some of the sort of very key changes, but null pointer is something that I forgot. So in old C++, you often use null, all in capitals, capital N-U-L-L, and C++11 introduces a new keyword, null pointer, N-U-L-L-P-T-R, all lowercase, which represents a null pointer. There are a number of reasons for using it, but it's safer generally and clearer as well. So another question. Do we talk about Clang and C++11 and compiler or pre-compiler and IDE peculiarities or concepts? Partly. So coming up soon after this Q&A, we have sort of a conversation with Patrick Scheller and Bruneau Babet. They're sort of talking about all sorts of things really as a free conversation, but part of the stuff they talk about is the history of why we moved to use Clang-based compilers. So you might have noticed in the talk that we just gave, I turned off the classic compiler, that is the old compiler, and then we were using the new Clang-based compiler for the code. So we extend Clang and we have a bunch of extensions. So Patrick and Bruneau sort of, Bruneau, touch on that kind of thing. They talk about why we use Clang and the various things it does and what it gives for us and how we integrate it into the IDE and using it for code completion and that kind of thing. So stick around for that talk if you're interested in that. You mentioned the free compiler as well, and yes, we have a free compiler which is completely free to download. It's just the command line compiler. You can get that on Embarcadero.com, and there's many free tools. And that's the Clang-based Win32 compiler. So if you're interested in using Clang on Windows, then by all means go and download that and use it. So question, could not properly understand what is the reason for square bracket reference map square bracket in the previous example. So that was the Lambda. Jim, I don't suppose you could sort of scroll back in the video a bit, please, until we could see the code. Thanks. So while Jim's doing that, I'll talk about that anyway. Ah, fantastic. That's perfect. So if you look at the code here, the Lambda is the bit mostly on the second line. So for each is the algorithm, and it runs. Oops, that video is now playing and has gone off screen. Okay, so down near the bottom of the screen, you can see that. For each is the algorithm. It's built into the standard library, and it runs over all items or all elements of the items vector. Begin and end are iterators. And reference map means that the Lambda that you can see there is aware of the map variable. Otherwise, the function is only aware of the parameters that it's given. So if you look at the body of the Lambda, you can see that it's passed one integer, which is because items is a vector of ints, and it's run on every item. That's each item. But it wants to know about the map as well, and it wants to use map further on where it says map square bracket n square bracket. And to do that, it needs to be made aware of map. So it binds or captures the map variable. And we do that by reference instead of by value, because we don't really want to make a copy of map. We just want to access the map that actually exists. So a question about smart pointers. Are the smart pointers in the STL equivalent to the new C++11 compiler's pointers? Well, the new ones in C++11 are in the new C++11 STL, but you're probably referring to the old auto pointer or to Boost's shared pointer or scoped pointer. So auto pointer was one of the very early attempts to make a smart pointer, and it was problematic for several reasons, and the sort of general advice is don't use it. It causes problems. Boost came along and created two fantastic smart pointers, scoped pointer and shared pointer. Shared pointer in Boost pretty much went into C++11 as is, and unique pointer in C++11 is quite similar to scope pointer with a few tweaks. So if you're using Boost, you can already use some of those techniques. The reason to show it here for C++11 is that those two smart pointers, unique pointer and shared pointer, are now part of the C++ standard. You don't require external libraries to use them. The other thing is that in modern C++, a general guideline is never to manually control the lifetime of an object. If you have delete anywhere, that indicates a bit of a code smell. And so one of the things I really wanted to show here, obviously it was a very small amount of code, I wanted to fit all the code on the screen. One of the things I wanted to show here was the importance of never manually managing the lifetime of an object. So more questions. I want to assign to a pointer the value of a pointer to a function in order to change the function which must be executed. Is there a different procedure which is suggested in C++? So in C and C++, you can get a pointer to a method and use that. You can call that method. And of course you can still do that in C++11. I'm not completely certain I'm going to answer your question here, so if you need a clarification, please ask a follow-up question. But I think the recommended C++11 approach is to use a lambda, which is a function object, instead of a plain function pointer. So next question, the unique pointer will be destroyed before the close curly bracket or when? So Jim, could you perhaps scrub through the video again a bit just to get to where the code is scrolled down a bit, please? But the unique pointer is destroyed when the block ends. So the block is defined, fantastic, thank you. Actually, maybe forward in the video a bit so we can see the use of unique pointer for foo. So the lifetime of the unique pointer or any sort of stack-based object is based on the where it's declared and the block it's in. So if it's items, for example, that's declared in the block that is the whole doStuff method. And items will be destroyed when the whole doStuff method ends. And the same for the unique pointer. When we put the extra braces around, that was to demonstrate creating that block. And the unique pointer will be destroyed at the ending curly brace, because that's the end of the block. Do we have those links or something else we can send? Yes, absolutely we do. We're going to put a blog post up today, which will have all this material and also the source code that you can download. Is there a smart pointer-like object that allows a lambda to be called when it goes out of scope to provide try-finally-like behavior for situations where you have to interface with plain C code and resources must be released manually? I'm actually not certain of anything in the STL that does that, but the pattern you're talking about there, the RAII, resource acquisition is initialization, is a common C++ pattern. Where you create an object that is given a resource, and when it goes out of scope, it looks after destroying that resource. Now, I'm not certain of anything that exists in the STL where you pass it a lambda to do something. It would be quite easy to write one. You would just write a struct that accepts a lambda. This would probably be a templatized struct for C++11, and then in its destructor, it would call the lambda that had been given in its constructor. So can CPP and H files in C++ Builder be exchanged with applications developed in other generic C++? Yes, of course. So we have a lot of sort of compiler extensions and frameworks, like our cross-platform frameworks, our database frameworks, and that kind of thing. And so, of course, when you use those in C++ Builder, you need those frameworks which come with C++ Builder. But if you write pure C++ code and you're not sort of taking advantage of any of the cross-platform things or the database things or the networking things or anything like that, then the C++ can be compiled with any compiler, sure. What is Clang? That's an excellent question. We'll probably touch on this in the next video, but Clang is an open source C and C++ compiler. It does Objective-C and other things as well. It uses LLVM for the back end, and that's like a low. What LLVM stands for low-level virtual machine, and the combination of the two results in very well optimized and standards-compliant C++ code. Is C++ 11 backwards compatible? Yes, it is. So one of the good things here is that you can switch to using the new Clang compilers, and you can use your old code. So there are few very small compatibility things. Most of those are between our old classic compiler that did things in a certain way and the new Clang compiler. We have excellent documentation about that, and it's not hard to change any of the things that need changing. I've done that myself for quite large projects. So yes, C++ 11 is definitely backwards compatible to the old C++. About smart pointers, is there any specific reason to use unique pointer instead of auto pointer? Yes, auto pointer was not a very good smart pointer, and one of the big problems with it came when you stored auto pointers in the containers. Unique pointer is much safer, and the semantics of ownership are much closer to what you would expect. That's probably quite complex to get into now, and I would have to double check to make sure I tell you exactly the right thing for what those semantics are. But we'll have some resources in the blog post where you can look up exactly how a unique pointer behaves. In general, never use auto pointer and try and use unique pointer or shared pointer. Can we share those materials? Yes, we'll put a blog post up with the source code here as well as a whole bunch of links as well. What would you use a for each with a lambda function rather than a standard for loop? Well, there are a couple of reasons to that. Look, you can use a standard for loop if you want, but what's good about using one of the algorithms, and for each is one of many algorithms. The standard library comes with lots of others, is that it gets you into the mode of thinking of making use of the algorithms and not concentrating on the implementation. So when you write a for loop, you actually concentrate on telling the compiler what to do. You're saying that you have to go from begin to end and that kind of thing. When you use an algorithm of any sort, you're not actually worrying about the implementation. You're not saying it goes in order or anything like that. You're just saying do something for each item, and you don't particularly mind about how that is achieved. So I think that's probably the best explanation I can give at the moment. It's more sort of a mode of thinking of getting away from saying how something does it to what something does. So would it be possible to implement some kind of typing hint to simplify hinting references to members of dynamically allocated objects by typing dot? So when you type the dot or arrow operators in the IDE, you can invoke code completion. And I would recommend you do this with the new compilers rather than the old one, because we have better code completion support with the new compilers. So by default with the IDE, when you type the dot or arrow operators, after a short pause it will show something. You can also invoke that with control space immediately. And it will show you a sort of a filtered list of items that the compiler thinks you might want to type. That's actually something we're actively working on, and we're going to be improving that as well in upcoming versions. In the Lambda, is n being incremented? Not in the Lambda itself. The Lambda is run on every item, or sorry, every element of the item's vector. and so each time the lambda is called, n will have a different value. The vector contains 1, 2, and 3, and so the lambda will be called 3 times, and n will be 1, and the next time it will be 2, and the next time it will be 3. In the lambda function example, we have a reference to the map variable. Is it possible to refer to more than one variable in the beginning square brackets? For instance, reference map, reference vec. Yes, absolutely. You can put anything in there that you want. So you can have, you can bind or capture to as many variables as you want. So you could reference to map and reference to items. You can also type in this. So if you happen to be in a class method and you want to give a reference to the object, to this in the method that is using the lambda, you can also capture this. If one uses Clang, just how far from the C standard am I going? I want to learn a language that is as universally accepted as possible. Clang is an excellent standards compliant compiler, so if you use Clang, you're safe. We actually add quite a few extensions to Clang, but you don't need to use them if you don't want to. We have them in there for a lot of reasons, not least of which is that they're very useful. And Bruno and Patrick actually talk about some of those extensions in the talk that is on after this Q&A. But if you stick to Clang, then you'll absolutely learn modern standards compliant good C++ code. And that includes our Clang compilers. When I say code smell, am I saying that it's an indication of bad code? Yes, code smell it doesn't say that necessarily is bad code, but it's sort of an indicator. Sometimes when you browse code, you sort of see something that you might think, okay, this might indicate or probably indicates a problem, some kind of architectural problem or design problem or understanding problem or something like that. And the general term for those kind of things is code smell. So if I place a series of buttons on a form, is there a way to use a vector to iterate through those buttons or other objects to make changes to them? So when you place buttons on a form, the form actually has a list already of all the controls that are on the form. That's not just buttons, but everything. And you can loop through that. What you would do is probably loop through it and check if each control is a button by checking with a cast. A dynamic cast is it a T button. But of course you could also add all the buttons to a vector and then you show it through that if you want. Does C++ Builder support C99 as well? Yes. When you go File New Project, you can create a new console application, for example. You can choose whether you want a C or C++ console application. What is Llvm? Is it related to C and C++ and to Delphi? So Llvm is a fantastic open source project. Llvm stands for Low-Level Virtual Machine, and it's used by compilers. So you have the front end of a compiler that takes the source code that you can see in front of you and outputs a sort of intermediate level code. And Llvm takes that and optimizes it and produces the machine code output. So Clang, for example, like our new compilers which use Clang as well as Clang itself, use Llvm as a backend, and that's one way that they get really well optimized code. Now Delphi also uses Llvm as a backend for the mobile compilers, so when you happen to use Delphi for iOS or Android or Linux actually, which is coming in a few months for C++ as well, it uses Llvm as a backend as well. Okay, for C++ Novice, what adds the Boost library? So Boost is installable through Getit. So in the Tools menu, we have the Getit package manager, and Boost should be available through that. I had a support question yesterday actually where it wasn't showing up for users of Starter, but you can actually download and install it separately if you need to. So feel free to email me if you need instructions to do that. Can we show or discuss connections to databases? I'm not sure if we have any material on that this week, but like the Pro and Enterprise editions of C++ Builder have fantastic database support, especially through FIDAC, which is our cross-platform database framework. It supports, I don't know, dozens of different databases. And we have lots of code samples that show that. So we have a lot of samples up on SourceForge, and you can download those and have a look at the code that uses FIDAC. So there's a point about the pointer names I was using for foo. So where the class was uppercase f foo and the unique pointer that I used was lowercase f foo, and that being confusing. That's probably true, so apologies for any confusion there. C++ is a case-sensitive language, and that can actually be a confusing thing. Is the parallel processing variant for each loop. We have the parallel processing library, which is a library that we provide for doing a lot of parallel work. And the way to do something like that would be, I'm actually going to have to double check here, so I might leave this to Jim to answer, but I believe we have a way of iterating over lots of things and doing something for everything, yes. Normally with the parallel processing library, you give it a bunch of tasks, which is sort of a high-level representation of just work to do. And it just goes away and does them. Is there any place that lists the non-C++ 11 or the extensions that we've introduced? Yes, all those are documented very well on our doc wiki. So that's docwiki, docwiki.embarcadero.com. Can we display web pages as part of a desktop application to make a browser as part of our application? Yes. So we have a T web browser control, and you can use that for desktop or for mobile applications, and that lets you access the internet and create a browser. How can I pass a unique pointer to a function which needs a normal pointer? Unique pointer has a get method that lets you access the pointer that it contains without removing the pointer from the unique pointer object. So just to see or get the pointer that it is holding without changing the ownership. So you can use that to pass it to a function that needs a normal pointer. In general, though, in C++, it's good to use references when possible, and if you're certain that the unique pointer object that you're holding actually contains a valid pointer, which it almost always should, it would be a very rare situation for you to initialize it or set it to null pointer. Then what would be better would be to change the method to take a reference, and then you can dereference the unique pointer. The code I showed was *foo to dereference that and make the method take a reference to the object rather than a pointer. Can I explain the this keyword? Yes, so we didn't really examine very much about classes in this very quick talk, although foo is a class, and so in the downloadable code you can have a look. So when you have an instance of a class and you call a method on that instance, that is on an object, when you're in a method that is running on an object, this is a pointer that refers to the object that the method is running on. It's a kind of self, if you were used to Delphi, or some other sort of way of indicating the particular object that the method is running on at the moment, the instance. Can we show an example of how to link code to a UI control? Yes, actually that was probably covered yesterday. Jim gave a really nice talk about UI frameworks, and what we had back then was when you had controls, there was the object inspector that was located on the left-hand side of the IDE. That of course you can put that wherever you want, and events, and so you can just double-click an event and it will automatically create a method that is called when an event occurs. And so that's an easy way to to have code that runs when a UI control has certain things happen. Those are events like when something is clicked or when a mouse moves or when a user types or something like that. We'll also go into a lot of that kind of thing with some of the examples that you can download. Tomorrow, for example, Eli is looking over games, and of course there are a lot of UI items in a game, and he may cover some of that as well. Can I show again how to enable the Clang compiler in Rad Studio? So if you go to the project options, so you right-click the project, options is down the bottom of the right-click menu. Then in the compiler section, you will see an option, Use Classic Born Compiler. And what you do is uncheck that. Is the sample available on MongoDB? Yes, we have lots of samples showing all sorts of database support. For database, you do need the Pro or Enterprise editions depending on what you do with databases. But yes, we support MongoDB and we have samples showing that. When will the session video be uploaded to YouTube? Later today. We'll try and get it up as soon as possible, so later today or maybe tomorrow. And I think unless I've missed everything, that's the majority of the questions. There are a couple I probably haven't answered, but feel free to email me as well at david.millington@embarcadero.com.
There's been a few questions about Inline Assembler, and the Clang Enhanced compiler supports Inline Assembler, and the Delphi compilers support Inline Assembler. The classic C++ compiler doesn't. So I put a link to the Clang documentation about using Inline Assembler. It needs to adhere to the GCC compatible language syntax for Inline Assembler. You can also use external assembly files and include them as well. There was a question along the way about what about Objective-C code, and I put a link to the project manager. If you say project manager, right mouse click and say add to add a source file or add new, you can go to the file template other. So add new file, add new source file, go to other, and you can choose Objective-C++, and that will create a .mm file in the editor, and you can type in Objective-C and C++ code there, or you can add a .mm file to your project. So if you're doing Mac OS or iOS development, then that's supported because we get it for free, just as we get C99 in the Clang Enhanced compilers versus using the classic compiler. There was some discussion about using Delphi code in C++. You can do that. We do that, of course, because of the runtime library and everything else, but not the other way around. You can't put C++ in Delphi. That's a little harder. And if you're going to use Delphi code in your C++ projects, whether it's through components or libraries, I put a link to some things that you should think about, some Delphi-isms like Delphi anonymous methods and so on, and generics is another one, and how to handle those in a C++ way. We do that, for example, under the covers by supporting the parallel programming library, which is implemented in Delphi. The futures use a generic variable that you pass the type into the future in the parallel programming library. I showed those on Monday. And so under the covers, we handle using that kind of Delphi generics and getting the type information and so on. So there's a few things about how to deal with Delphi language constructs in a C++ project, and I put the link to the doc wiki that discusses those different aspects. I did put a link, I think it was in the chat window, about some of the C++ Builder keyword extensions that we made. That's in the chat window, and there's a whole set of them. They have underbar in front of them. Many of them have to do with using decal spec for things like denoting something as a Delphi record or a Delphi class, or it's Delphi RTTI. We also added some extensions specifically for Windows functionality. For example, like DLL import, DLL export, and so on, UUID to create a GUID, those kinds of things. Since we were the first Clang enhanced compiler to support Windows, we did that for the 64-bit version of C++ Builder first. We needed to add some extensions to the C++ keyword list to support some of those specific Windows isms as well. We also added some extensions for try and finally by having underbar as it relates to exception handling. There's a whole great discussion and a Code Rage, I think it was Code Rage 9 conversation with Eli Bowling on the C++ team about how we handle exception handling on different platforms. Windows, it's structured exception handling, and then it's different on different platforms that you might move to in the future from the starter edition. So those were some of I think, the key additional questions that came along during the conversation. There was discussion about, again, running the products side by side, and then there was a discussion about you have all of these paths in your Windows system environment variable for version 18 versus 17 versus 16, which are the underlying version numbers that our products use to version timestamp. And I pointed to a tools options environment variable setting in the IDE, which allows you to override in each of your IDEs system environment variables, as well as set other local environment variables when you're building and running an application inside of the IDE. So if you have multiple versions of either Delphi or C++ Builder or Rad Studio, and you're suffering from that whole Windows system environment variable path chaos, you can set the right environment variables that you want for each of your versions in the IDE, again, using tools, options, and then in that tree view, choose environment variables. And there's information that lets you create your own IDE-based system paths, for example, and override the global Windows system paths, at least while you're in the IDE and compiling and running applications. I don't know if there was other things, because we're getting close to, again, the top of the hour. David, did you see anything else come in along the way? Maybe not. There was some discussion about Qt or Qt libraries, again, for doing other graphics. We haven't done anything with Qt. We did that many years ago. We were working with Qt back in the C++, maybe it was version 3, version 4, when we were doing Qt-based Linux GUI development, but we don't do anything with Qt today, and I don't know of anybody who's done anything either with our C++ Builder recent versions, so as far as bindings for those libraries.
A couple of questions about mixing C++ and Delphi. So when you have Rad Studio, you can have a project that has both C++ and Delphi in it, and C++ Builder consumes Delphi code. I mean, the compiler can actually emit C++ header files for the Delphi code and that kind of thing. But it doesn't really go the other way around. Like when you create C++ code, you can't really easily consume that in Delphi. But what you usually end up with is a project that is officially a C++ project, but it contains a lot of source files in both languages.
Yeah, I mean, one way to deal with some of this is to put code in, if it's Windows target, or it's Mac OS target, or if it's Android target, you can either create static libraries, you can create DLLs and export functions in C++ as C exported functions. And then if they're in a DLL or a dylib or a .so, then you can link with the C calling convention interface. The challenge is the name mangling of C++ that mangles functions, it's very hard for a non-C++ compiler to be able to figure out how to find the right functions when it's trying to link. So exporting C++ functions as C interfaces, C calling conventions, makes it very easy for Delphi or Python or some other language that doesn't know about C++ name mangling of functions to do those. And so Python and other things will tell you, if you want to use a C++ library, export functions with names that can be used, for example. There was some discussion about other instructions, hardware instruction sets like MMX and so on. We do support the registers for the Intel enhanced instructions for MMX and SSE. Those things, you'll see those in the CPU viewer, for example. There's a floating point view versus the CPU view and such. But really you should look at Clang and what Clang supports. Somebody asked about VST, for example, for digital signal processing. I don't know if, and I looked, I couldn't find any specific Clang or LLVM support. There are some libraries that you might link with so that export functions, but I didn't find anything native in the language or extensions for some of those hardware-specific low-level calls. Someone out there may have an LLVM toolchain compiler extension. I know that you can use CUDA. There's a CUDA extension for doing inline CUDA, NVIDIA, low-level GPU programming. We haven't done anything with that specifically in our Clang-enhanced compilers, but I know that that's available out there in the.
So one question was, what's the difference between cout and wcout? Well, cout is a narrow character outstream, that is a 1-byte character outstream, and wcout deals with wide characters, so it's Unicode aware. You often see cout in most C++ example source code. I use wcout here because I quite like using Unicode aware strings. And a very closely related question actually is, what is the L in a string? So in the code I had something like L $ONE for one close quote mark, indicating a string with an L prefix. And that L indicates that the string uses double byte characters, so one character is represented by 2 bytes, whereas the normal is 1 byte, and it's very similar to the, it's just the same thing effectively as the narrow and wide outstreams. And that makes the string Unicode aware. I didn't actually use any unusual Unicode characters in this particular demonstration, but the strings could have handled them had I done so. What is std::? That indicates the standard namespace. So std holds all of the STL, which is the standard template library, which is a key part of C++. And what is Boost? So Boost is a great third-party C++ library. It's very widely used, and it contains lots of useful stuff. You can install it via Get It. So in the Tools menu, there's a menu item, Get It Package, Get It Package Manager, and Boost is available there. And I had a couple of reports yesterday that it wasn't showing up for some people with Starter, but if you drop me an email, david.millington@embarcadero.com, I can provide instructions for manually installing it. There's a question here. With the Lambda function, the code using the for each algorithm became more difficult. I suppose that depends how you view it, but there are a couple of benefits, I think. The first is that the function is visible and readable at the point where it's run. When you have a functor object, that functor is defined somewhere else, and you just see the name that you pass into the algorithm. You don't really know, you can't see what it's doing, and it's really nice to actually see the code. If you're applying something to a collection, you want to see what that is. And so a lambda lets you actually see the code because you write it at the point where it's actually run and applied. Another reason is that a functor requires an entire struct to exist somewhere, and that tends to pollute the namespace. It only exists for one purpose, but it has to exist outside where it's used. So those are a couple of reasons why a lambda function might be better than a functor object. Let me scroll through some of the other questions. How is the n incremented in the lambda of my code? Jim, would you mind scrolling backwards slightly, please, so we could see the last code screenshot? And while Jim's doing that, I'll answer the question. So for each is an algorithm, and it effectively implements a loop. The thing here is that it lets you declare the intent of what you're doing rather than actually implementing a loop. So it simply says that you want to run something over every element. You don't actually have to specify that it's done in a loop, for example. The implementation is hidden, so you're declaring the intent of your code. And what happens is that the lambda which is passed in is then run on every element of the code. So n was a parameter to the lambda function, and because we're running on items, which is a vector of ints, n was an int, and so each element of items was passed into n. So it wasn't that n was incremented, rather what happened is that the lambda was called where n was equal to the value of each one of the elements in the items collection. I hope that's a good explanation. Does the FMX, the FireMonkey framework, work with the Starter edition? Yes, it does. So Starter includes both the VCL and FMX. Starter is for Windows only, but FMX is a cross-platform framework, and you can actually make cross-platform ready applications in Starter, so you can do a lot of the work about the multi-device design and that kind of thing using FMX in Starter before you get the Pro and Mobile edition, which lets you build and deploy to iOS and Android and platforms like that. So, isn't it a good idea to pass a reference to a shared pointer? Doesn't it rely on a copy constructor to do proper ref counting? Yes, it does. But when you pass a reference to a shared pointer, the shared pointer that you're passing reference to still exists somewhere. And so you don't actually need to increment or decrement the ref counts in that particular situation. But I would normally not recommend passing a reference or passing in any way a smart pointer. The reason for that is that you would only pass a smart pointer object in a parameter, say, when you want the method that you're passing to actually do something with the smart pointer itself, not with the object that's being pointed to. So for example, if you have a smart pointer and you're passing it to a method or in a constructor, for example, and you want the object that's being constructed to take a reference, then you would pass the shared pointer. But if you're simply calling a method and it operates on a pointer or reference of a particular type, just pass the pointer or reference to that particular type. The reason for that is that it keeps very clear the ownership semantics versus the use of the object itself. If you start passing a smart pointer around, it becomes very difficult to see in your code at what point ownership is intended to change. Because the only reason to pass the smart pointer object is if you need to use the smart pointer itself. And usually the only reason for that is if you intend to change the ownership or take another reference or something like that. Where are we? Do we have a blog link? I don't see yours on the Embarcadero blogs menu. That's a good point. I don't think I'm actually listed on the Embarcadero blogs menu, but my blog posts show up in the blog feed, and I can look into getting myself listed on the menu. So Okay, so here's a good question. I don't really see the use of a lambda function. If I wanted the code for the function inline, I would just put it there. In your example, I could have just as easily taken your vector map functor code and placed it directly in line with the for loop. So what did using the lambda format really save? So that's a very good question. The first is, let me begin with the approach of using an algorithm instead of a for loop. So for each algorithm and the for loop, just iterating over the entire contents of a container, achieve the same thing. But one states the intent. It says that you just want to do something to every item. And the second actually requires a lot of boilerplate code to implement doing everything to each item. And it's unnecessary code. There is no reason to actually write a for loop when you have something that looks after that for you. And writing extra code like that can introduce bugs as well. I mean, you might, for example, write the iterator equals items.begin, iterator equals items.end instead of not equals without noticing, and there you've introduced a bug. And it's better to make use of the inbuilt algorithms that avoid actually having to write code. First of all, because you don't write code, and second, because it means that your code only states the intent of what you do and doesn't actually specify how that is done. So with that as background, for something like for each, you need to pass in a function of some sort, so a functor or a lambda. And that's the reason to use a lambda is because you want to see what is applied to each element there. I'm not quite certain I'm explaining it very well, but the key here is to see the intent of what you want to achieve versus actually writing all the code that is required to go ahead and achieve it. The other thing is that this was quite a simple example using lambdas, but it can be very common to have a whole bunch of sort of callback functions or functions that are applied and called on data in all sorts of ways. And passing a lambda in there is something that you would definitely do, and that's code that can't be described using a for loop. You might have a function that is passed to something else and then used much later. So what happened to OWL? OWL is the Object Windows library, a very old library now written in C++ for creating sort of Windows applications. I believe it's actually still going on. People still use it, even though it's about 20 years old. We would highly recommend now that you use either the VCL or FMX, because the OWL's direct replacement was the VCL, of course. And the VCL is great for creating Windows applications. It wraps native Windows controls and does so in a much more sort of visual and user-friendly and easy to use, and I would say probably more powerful manner than OWL ever did. It's certainly a lot more flexible and a lot more easy to create good user interfaces. And FMX is great not only for Windows but also for cross-platform. It's GPU powered and all that kind of thing. Jim gave a great overview of FMX in yesterday's session. So where are we? How complex should a lambda get before turning it into a complete function? Well, that's a good question. I suppose when it starts becoming unclear to read. So one of the nice things about lambdas is that they're at the place where they're actually executed. So you can see the code that is run at the place where it is run. Here in the for each, for example. But if that lambda was really, really, really long, it would start obscuring the meaning of the code. It would become harder to see what is actually happening in your code. Where that point occurs is, I suppose, a matter of personal taste or how many lines of code you can fit on your screen or something like that. But I would say it's just a matter of clarity. At what point does it start becoming unclear code? I've never used a unit. What's the point of this? Is there any big advantages to grouping the H and CPP in this unit file? Well, the unit isn't one file, it's two. It's the CPP and the H, but the IDE recognizes that the two belong together. And so in C++, you'll often have the pairs of a CPP file and a header file. And so using unit is just a really nice way to make the IDE aware of the connection between the two. So the pair of the CPP and H will show up as one single item in the project manager, and you'll have tabs down the bottom of the code editor to swap between the header and the implementation of the same logical unit. I suppose that's where the name unit comes from, the same sort of logical related unit of code. The shortcut keys as well, so you can swap between the CPP and the header as well with Control F6, I think. Just scrolling through a few more questions. So another question about lambdas, the benefit, quoting that the benefit is that you see the function that is applied at the point where it's run. And the question here is that with the right name of the function, it can describe what the function does and minimizes code. Look, that's quite true, and with a well-named function, it will describe what the function does. But don't forget as well, for a functor object, you have to create an entire struct just to have one overloaded operator bracket. It's a huge amount of sort of extra code that you shouldn't really have to write just to write a function. And it pollutes the namespace as well. You have this whole struct just floating around somewhere that is really only intended for a single localized spot, but has to be up in a much higher scope level where it's visible to everything. So using a lambda is cleaner in that sense as well. Comment here, R was great, but the time to move on was years ago. Yes, I absolutely agree. Yeah, definitely should be using the VCL or FMX these days. So, yes, a good point here. If you have a form as well that is treated as part of the unit, so when you have a form that's part of the visual designer, then you have the form design, and then you have the header and the implementation CPP file, and all three of those are grouped together by the IDE and regarded as a single unit. That's very useful. It really helps when an IDE keeps track of related things like that. Is there any information about the various strings? I know there's string, W string, there's also Unicode string. Yes, all of these will be documented either in our own doc-wiki or when they're part of C++ itself in, say, cppreference.com, which is an excellent reference. As a quick overview for the three you mentioned, string and W string are inbuilt C++ STL string types. The difference is that W string is wide, it uses wide characters. Unicode string is a Delphi type that is exposed to C++. In C++, things like strings are just implemented through libraries. In Delphi, things like strings are inbuilt. They're native parts of the language. And so Unicode string is how that Delphi type is exposed to C++ when you happen to mix Delphi and C++ code. So I think we've scrolled roughly to the bottom of the questions now. I have skipped a few. And if I haven't answered your question, then please feel free to email me at david.millington@embarcadero.com. But Jim or David, can you see any other questions that I should perhaps answer?
There was a question about smart pointers, David smart pointer versus unique, or shared pointer versus unique pointer. And function argument types.
Right. Sorry, I can't see that question. Would you mind reading it out, please?
It says, from the presentation, unique pointer is not recommended as function argument type. What about shared pointer? This is at 11:27 a.m.
Right. Look, I would say that recommendation goes for smart pointers in general, and the reason for that is that you want to be clear about the ownership of the pointer. So I would pass a shared pointer in a function or in a constructor when you when the code that you're passing it to is also going to want to use a shared pointer. So for example, you pass it to the constructor of a class. That class is going to keep a reference in a shared pointer member field, and so you would pass the shared pointer itself. And that way you know that the pointer that is wrapped is being handled by a shared pointer. And the ownership is clear. Like the fact that you pass a shared pointer in the constructor arguments indicates that you're going to do something with the shared pointer itself. In this case, you're going to use the copy constructor, and you can have another shared pointer field pointing to the same wrapped pointer. Whereas if you just have a normal function that wants to operate on the type that is contained by the shared pointer, then it becomes a bit confusing. You can come back later and you can read the code, and that function will have to dereference the shared pointer and then act on the object. When you come back and you read the code, it can be hard to know the intent. Because the shared pointer is passed there, you need to ask the question, is this function past the shared pointer just because it wants to operate on the pointer that's held inside it, or is it because there's something happening with the ownership of pointers here? And if all you're doing is you're operating on the wrapped pointer itself, then I would pass just the wrapped pointer, or even better, I would pass a reference, so dereference the wrapped pointer and pass a reference to the object, to the method. Does that answer the question? I hope so. David or Jim, are there any other questions that I should answer?
I don't.
There's a couple new ones that just came in here. Okay. This is Jim. One is asking if there's a way to implement Delphi helper classes in C++. And the other one's asking if you would also need to release the reference in your destructor. I'm guessing that's in reference to what you were just talking about.
So to release the reference in the destructor, if that is related to what I was just talking about, so you have a smart pointer that is a field in a class, then no, you don't need to do anything about that, because the point of the smart pointers is that they release or free or delete what they're pointing to at the appropriate time. So for a unique pointer, that's when it is destroyed, such as when it goes out of scope. But if you have a unique pointer member field, then when the object that holds it is destroyed, all its fields are destroyed. That includes the smart pointer field, and so it would then delete the item that it's pointing to. For a shared pointer, it's reference counted, but the same thing happens. And so that means that no, you don't need to worry about deleting the pointer in the destructor of a class when the lifetime of that pointer is managed by the smart pointer object. So yes, also, is there a way to implement Delphi helper classes in C++? I don't believe so. I think you have to implement Delphi helper methods in Delphi itself. There's a question here as well. Is there functionality so that from a header file you can also auto-create the CPP skeleton file with all the functions and classes in the header? Not right now, but that's a very useful idea. So yeah, that would certainly be a cool thing to add. So, are there any other questions?
There was a question here about how can you tell how many references are remaining for a shared pointer?
To be honest, I'm not completely certain, but I know that there is a way to do it. I mean, obviously the shared pointer itself manages the reference count, so you can access the reference count that it's using. But I'm not certain of if that is actually publicly exposed as a method on the shared pointer item. I would have to look that up. I'm sure it would be in the shared pointer documentation.
There is a method called use count. Use count.
Right. That sounds exactly perfect. Yeah. Question about starting and developing an application with one target platform and making it cross-platform later. So yes, you can certainly do that. I would suggest starting with FMX, that's the cross-platform UE framework. And so, for example, the Starter Edition, which hopefully you have for free through the promotion this week, you can build Windows apps, but you can make use of the multi-device designer and that kind of thing to make your app cross-platform ready, so that you can later, if you get Pro and mobile, build and deploy to other platforms. There's a question here about method toxicity metrics. So what are they for? And they help measure bad code, I suppose, like how complex code is, or how likely it is a method will be clearer or cleaner if it's split up or refactored.
Yeah, some of the things it looks at typically is length of procedures or lengths of methods and how many code paths methods have and things like those. And so it's a guideline. It's like you said earlier, code smells. It doesn't mean that the code is broken, doesn't mean that the code is bad, but it could mean that it could be simpler and easier to maintain. And if you consider how much time you spend maintaining code, that can be a good thing.
There's a question here about using a DLL built in Visual Studio from C++. So I clarified that, and when you use what we call plain old data types, like a C interface effectively, that's trivial. I mean, you can easily use a DLL from the C++ builder, or the Windows DLLs are examples of doing that kind of thing, for example. So you just need the header and perhaps link to the lib. A couple of comments about Turbo C++. It certainly is very old now, but yeah, that's one of the reasons we released the new free compiler, was to to make a sort of new modern compiler available for people who are still using some of that old technology. Comment: after this boot camp, I love lambdas. Well, that's fantastic to hear. And a question about auto as well. So if you have some code, auto f equals 0.0, is it a float or a double? The answer there is it would be a double. It would be a float if it was 0.0f. And that's, to me, I think that's a good example of when not to use auto, because you don't actually gain anything there. Auto is really good when the types are very complex or very lengthy, or when you actually don't even know the type. So when you use a lambda, for example, you can assign that to a variable. You don't want to have to even try, if it's even possible, you don't have to try to figure out what the type of that lambda is. You just use auto. But for something like a simple number, a floating point or an integer or something, sticking to the actual data type is a good idea there. And I think most of the rest of the questions are just saying, oh, that was great, and thank you. That was fantastic. So thank you everyone who's sent in a comment like that. And I think that's about it. Unless Jim, you can see any questions that we should answer.
I think we've got it. So if anybody else wants to save the Q&A log, we certainly can do that now. And we'll look forward to seeing everybody tomorrow with game development. And as I mentioned before, I saw a preview of some of this stuff. It's really, really cool. Even if you're not planning to do game development, it touches on so many different pieces of technology that I'm sure you'll find some things that are useful.
That's an excellent point. So yes, look forward to seeing you all tomorrow for that, and Friday as well, which covers moving to mobile. So if you write a game tomorrow, for example, and then you want to look at deploying that to iOS or Android, Friday's the day for you. So thank you everyone, and goodbye.
Bye everybody.